correlation? A relationship. Right. See, what is it that we just studied in Chapter 9? Chapter 9 was the first time we looked at two populations instead of one, right? Two samples instead of one, right? So when you start studying two populations, well, I guess what we looked at is we looked at the differences between the proportions or the differences between the means. But sometimes what you want to say is that there is a correlation between the populations. It's like Scott said, a relationship. And I have to warn you that we're only going to skim the surface. Why? Because, yeah, we're really at the end of the course. I've taught other courses where we explore this in depth. So the basic concepts of correlation are what we're going to do first. So here's a definition. A correlation exists between two variables when the values of one are somehow associated with the values of the other in some way. But I really like Scott's definition. There's a relationship between the two variables, the two sets of values. And these are in the book, these definitions, but at least you can read it and get an idea. The kind of correlation we're going to talk about is what's called a linear correlation. And this is a very famous statistic, R. R is called the linear correlation coefficient. You guys may, actually, depending what you look at when you're doing your papers, some of you may come across this guy. They'll say, oh, the correlation coefficient is blah, blah. Or they may say R equals this. It measures the strength of the linear relationship between the paired quantitative x and y values. Oh, I have a group work in mind. We may do this on Tuesday. We'll see. Okay. But we often see a relationship between two variables when you construct a scatter plot. And figure 10.2 of your book has scatter plots. Okay? So, you know, I'll have to show you how to get a scatter plot also. I think I'll do that in a moment. Here is some data, right? And here is some data. And what we did was we had two data sets. One we plotted along the x-axis and one we plotted along the y-axis. And again, the idea here is that we have matched pairs. And what I'll do is I'll put one of the numbers in x and one of the numbers in y. Yeah, this is in your book. Here's what I'm going to do. I'm going to do something more instructive. All right? I'm going to pull out my calculator. And I'm going to show you how you can do this stuff. All right? So let's go to Stat. And let's edit the list. And I'm going to type right over these numbers. And what I think I'm going to use as data are the weights that we had in Chapter 9, Section 4. Let me find that. It was Table 9.1, wasn't it? I forget what page. Come on, Paul. I know we had it up here. Didn't I just do a sample with you guys of the freshman 15? There it is. Oh, example 5 does it. Here it is. Table 9.1 on page 489. So let me put down this list 1. These are going to be the April weights. 66 was the first weight. 66? How could that be? You know what they're measuring in? Kilograms, right. So I'm sorry, 66, 52, 68. Actually, if you have a calculator, you may want to try typing these in. 69 and 71. 66, 62, 68, 69, 71. Those are the April weights. And then in September, this person gained a kilogram, which is how many pounds? 2.2. 53. 64. This person lost 4 kilograms. Lost a lot of weight. 71. And 70. Okay. That's all you need for what I'm going to do. By the way, while people are typing, I'm going to show you that you can get the differences. This might help you guys on the homework. Here's how you get the differences. If you go on top of list 3 up here and press enter, it'll put you down, and now you can type in a formula. And if I hit second 1, there's L1, minus second 2, I'll get L2 there. It says now L3 equals L1 minus L2. Hey, there's my list back. Now you can get the mean and standard deviation of L3. You have everything you want. It's very cool. Okay. What I want to do is I want to construct a scatter plot of this data. And the way you do it is you hit, do you see the y equals button? That's what's used for graphing, but right above it in gold is written stat plot. Do you guys see that on your calculator? So if I hit second y equals, it tells me about my stat plots. And most of them are off. Now for me it says list 1 is on, number 1 is on. I'm going to press enter because I want to edit it. And it's asking me, do I want it on or off? Well, I want it on. And it's saying, what type of graph do you want? Now if you notice, the one that I have over here is the one highlighted. That's a histogram. That's because in the other class I just plotted a histogram. But for you guys, I want to do a scatter plot, and that's actually the very first one they show you. And when you do that, it says, okay, what do you want the x's to be? Well, I want them to be from list 1. Yeah, you just press enter, and it'll choose it. And then you could change which lists you're getting your x and y from, but I'm going to leave them like that. And then there's even different kinds of marks you can make. You can make a square or a plus or a dot. But once you're all done, you're ready to graph. Okay? Here's the trick, though. If you press the graph button, it probably won't give you a good graph. What you need to do is you need to press zoom, and you have to find zoom stat, which I forget is like choice 9 for me. But if you can hit zoom stat, it'll find your data and it'll plot it.
And that was after list 1, 2, or 3.
Well, I can check stat plot again to see. Here, let me show you. Mine was, X list was list 1 and the Y list was list 2.
So what was scatter plot represent?
Well, okay, let me show you. If you want to know what this stuff represents, a good way to do it, hit the trace button. Trace. And it'll show you, hey, here's one of the dots. X is 66. She was 66 kilograms in September and 67 kilograms in April, or he. Does that make sense?
So it's actually L3, but it'll show you...
No, this is L1. Look, it says L1, comma, L2. If I hit the right arrow, it'll go to a different data value. Here's someone that was 52 and is now 53. Here's someone that was 68 and is now 64. So these are the different values. Now, by the way, here's the question. Do I have enough data here to decide if it's lining up or not? The answer is no. You can't do that with 5 data points. But if you plot a lot of data, you might say, hey, this kind of lines up, and this kind of lines up. And what you do is you're looking at the slope of the line in a sense. If it's positive, that's called a positive correlation. If it's negative, that's called a negative correlation. And we'll talk more about slope next week. But Here's an example of no correlation. Do you see how that is not linear? If it's not linear, you can't say we have a linear correlation. All right. Now here's a nice example. Here, you could get software to give you an R value, but this is what they call a nonlinear relationship. And I may be testing your algebra skills, but does anyone know the shape that I'm drawing here? A parabola, yeah. But you guys all understand that's not linear? So everything that we're going to do linear in this chapter, you could do with curves also. But that's a little more technical than we want to get. I just want to show you that you can have relationships. How many would say there is a relationship between X and Y here? Yeah, there is a relationship, but it's not the relationship of a line. You guys follow that? I don't know. We're in the zoning mode. We're trying. Requirements. You know what I'm going to do. I'm going to do this because you're in the zoning mode. Okay, there are requirements. Notation. N. We know what that is, number of pairs. What's this mean? Okay, we know that means to add. What would this mean? Well, add up all the what? X's. What would this mean? This would mean first you want to square the X values before you add them. So actually, if I go back to my calculator, let me show you something. Let me go back to the list itself by hitting Stat, and I'll edit the lists, right? These are my X values. If I wanted to compute sum of the X squareds, right, you'd have to square each of these before you add them up.
Could you do that place 4?
Well, you could, but there's a better way. Let me show you. If I hit second, I'm sorry, I don't want to hit second. Yeah, second quit. I want to get out of here. See how I just did the one variable statistics of something? I'm going to do it again. When you do one variable statistics, look what happens. It gives you the sum of the x's, but it also gives you the sum of the x squareds. See that?
So you just arrow down, those values are in the
It's already there. It knows that that's something that we compute quite often in a stats class. So it did it for me. We're going to need it in our formula today. This is something different. This means get the sum of the x's and square it. So for example, on my calculator, I would take 326 and square it. And that is very different from this. If you take the sum of the x squareds, what did it say? It said 21,486. I guess I should compute what this is to show you it's different. You got 106,000? Okay, so you guys understand these are different quantities? That's something that they want to make sure you understand. Okay, notation. Oh, what would this mean? You have to take x and multiply by its corresponding y, right? So, for example, in our problem that we were doing, let me go back to the data again. If I edit the data, that would mean do 66 times 67, do 52 times 53, and then add all that up. You might say, why are they going over all this notation to compute R? Well, the reason is, look at the formula for R coming up. Oh, yeah, I should mention this. You know what that is? That's a Greek R. It's called rho. Of course, we use Greek letters when we're talking about populations, and we use regular letters when we're talking about samples, okay? So let's keep that in mind. Look at that crazy formula. Formula 10.1, it's in your book. R is all this crazy stuff. You have all these little things to compute. Holy mackerel. Hey, wait a minute. Good news. Computer software or calculators can compute R. It's in your book. Don't write that down. We just know that the computers can compute it, so hey, how do we do it? Well, let me show you. So, we have, what do you want to use? TI calculator? Yes. All right, let's show you how to do it. So it says, for R, I saw it before, it's actually quite simple. Where are we? $530, does it say? No. 530 or something. Let me find it. Ah, yeah, I had it bookmarked. Why didn't I look there? That's not what I want, though. Well, I guess it'll work. Okay, so if we hit the stat button, yeah, I should have showed you this a while ago. Well, look. Stat edit, right? Stat calc. But I noticed there's one that says tests. So you can do a z-test or a t-test. That's kind of neat.
You mean for z-score or t-score?
I think that's what that means, yeah. Anyways, the one I'm going to use is linear regression t-test. Where the heck is that? Linear regression t-test. It's choice G. For me, it's choice E. Linear regression t-test. It depends on your calculator, how many tests you have. All right, I'm going to press enter. When I press enter, it says, hey, where's your data? Well, I actually have data in list 1 and list 2, so I'll use that. Okay? It says, what's the frequency? Well, 1. It says, what is beta and rho? Do we think it's not equal to 0, or what do we think? Okay. Well, if I use that option, and I go down to calculate, I can press enter. And it gives me all kinds of stuff.
What was that equal to? How do you do that?
Well, all you do is you go down to calculate. All right, don't worry about choosing yet. All that is more complicated. It has to do with hypothesis testing for R.
Oh, we don't have to put it on.
Let's not go there. Well, I guess what I want to do is I want to point out that look what it gave me. R is 0.94.
That would be if we were looking for something else?
I'm sorry, what?
That would be if we were looking for something else? We would have had to have chosen something there, but you cannot choose something there?
Yeah. Let me say one thing. You guys have to understand something about this course. This is what's called elementary statistics, right? Okay? This calculator can do so much more than what I've shown you. All right? And, yeah, when you're asking me, let me go back to it and try it again. Here, maybe. Yeah, we do. Yeah, we do. But, I'm sorry, where was I? Okay. Here, tests. Oh, hey, I'll give you a hint. When you're going for this one, go up. Don't go down. Linear regression t-test. Okay, I press enter. You're asking me, hey, wait a minute. What do we think about rho? Does it not equal 0 or less than 0 or greater than 0? Doesn't that look like a lot like hypothesis testing? And notice it's for rho. Rho is the population correlation coefficient. And you could do tests on R as an estimator for rho. I just don't want to go there. Not with the amount of time we have left in the course. Okay?
We still have to worry about it.
Let's not worry about that. Yeah, don't worry about it. What do you have to be able to do? You have to be able to calculate. Put in what? Oh, I put it in. Yeah, that's right. So what would you do if you had a whole bunch of data? Either you type it all in, or if it's from StatDisk, maybe you could do it that way. StatDisk might be easier. Well, we're out of time. I will take a second look at that homework assignment and make sure that I'm not killing you guys, because I don't want to do that. All right? All right. Anyways, good work today. I think we learned some things. We'll do more with this chapter next week, okay? And let's see. I have 2 hours available now. If anyone wants extra help on homework, I'd be happy to still work with you, okay? I'm going to be in my office. Yeah, if anyone wants to turn in homework, I'll take it. If you have older homework, I'll take it, sure. Thank you. Thanks, you guys. Right. If you want to, yeah, I'll be here till 2.
Give me a half an hour.
Okay.
Okay, so I'll come back up.
Cool.
The paper to actually have to calculate my own data, or like, what I did was I was using multiple graphs to prove a point. So as long as I'm using my knowledge of like good and bad graphs, and also
You just need to demonstrate to me that you've learned some statistics in this course. I think you have. So that's the goal. All right? That's great. Thanks, John. Thanks, Gavin. Jeff. I saw it. Yeah.
Would I use like that entire year's earnings as my net?
That doesn't mean he's coming to Lakeland.
So it'd be like 900,000.
Rain Man. I think I would remember.
I don't know. No, that's not it.
No, but I remember Rain Man.
That's not n. That's a value, right? So
Yeah, I know.
yeah, you got to say what are you measuring?
I've never seen it, but I know.
I thought you were doing monthly earnings.
But okay, what's doing part of
I was doing.
You said that the winter months.
Well, yeah, I changed it to testing the claim that 50% of earnings are made on Friday and Saturday.
Oh, Friday and Saturday. Okay. So let's see.
So does that mean I'm allowed to learn about it in history?
Well, that's not a claim. You could actually just check that.
It's not World War II. That's not one.
But I don't know. I mean, I only have like one class, and I was gonna compare it to like.
Well, we can sit down and talk about it if you want. I have to think. I understand what you're asking. You're asking me, look, I have some pretty cool data. I've noticed that Friday and Saturday seems to be the days.
Well, yeah, just working there, I noticed that.
What can I say statistically? That's what you're asking me.